Okay, on to lesson 2.2 and the TIPP&SEE. First, let's do a little review on sequence. Here we have two partial scripts that use the same blocks. Are these two scripts the same or different? And can you explain why? If you look closely at the two partial scripts, they do use the same blocks, but the blocks are not in the same order or the same sequence, which means that the two partial scripts are different. The actions they will do follow different sequences. In the partial script on the left, first the sprite will move 10 steps, then play sound cheer, then change size by 10. In the partial script on the right, the sprite will play sound cheer first, then change size by 10, and finally move 10 steps. In this next partial script, we have more blocks. Can someone volunteer to describe the sequence of what will happen in order in this partial script? Look closely at the script and be specific and include all the information that you can see on each block. Teachers, this is a good opportunity for your students to verbalize the actions of each block in Scratch and also use the words first, then, finally, last to indicate a sequence of actions. Can someone describe what the change color effect block does? Correct. It doesn't change the color completely of a sprite. So a sprite that's red wouldn't change completely to green, but it makes the color either lighter or darker. So if your sprite was the color red, the change color effect by 25 block might make it a little bit darker red or a little bit lighter red every time the script runs. Here we have a sequence engage video to review a little bit more about sequences.
Wow, we have already learned so much about coding. Today, we are going to talk about a new topic, sequence. When I say the word sequence, what do you think of? When I think about sequence, I think about doing something in a certain order, like first you do this, next you do this, then you do this, and last you do that. When you list a sequence of actions or instructions in a certain order, it's called an algorithm. Let's create an algorithm for brushing our teeth. What do we do when we brush our teeth? What are the actions? I know I need to get out the toothpaste, a cup, and my toothbrush. I need to fill the cup with water and brush my teeth. Then rinse my mouth and put away the toothbrush, the cup, and the toothpaste. Did we miss any actions? Oh yeah, we have to put toothpaste on the toothbrush before we brush our teeth. Otherwise, my teeth wouldn't be very clean without using toothpaste. Something still doesn't seem quite right here. Oh yeah, the sequence of those steps and those actions is very important. I have to put toothpaste on the toothbrush before I brush my teeth. This is just one example of an algorithm I could use to brush my teeth. Sometimes there can be more than one way or one algorithm for completing a task. Do you know the difference between an algorithm and a program? A program and an algorithm are very similar, but a program is written so that a computer can understand it. I am writing a program in Scratch. Here is the algorithm for the program I am trying to write. I want my sprite to first think, where is my dog? Next say, I see her. Then walk or move across the stage to the dog. And last say, time to eat. Now this is my program or code that goes along with that algorithm. Let's run my program to see if it works. I'll click on the sprite. Oh, that's not quite right. Let's look a little bit closer at my program. Oh, the sequence of the actions isn't correct. They're not in the right order. The sprite should say, I see her before he moves. Let's put the actions in the correct sequence. All right, let's rerun the program now to see if it works. Yay, it works. So as you can see, the sequence of the actions in a program matters. Today, we are going to continue exploring in Scratch and learning about how a sequence of blocks or actions in a program is important. Have fun!
You may have seen the go-to XY block used in a script in a previous project. What does XY mean? XY is the same as the coordinate plane that you may have seen in your math class. X refers to the distance along the x-axis, and Y refers to the distance along the y-axis. If you remember from your math class, the x-axis goes left and right, and the y-axis goes up and down. The go-to XY block allows you to position a sprite somewhere on the stage by using this coordinate plane and adding a number into the white circle after the X and the white circle after the Y that represents a specific position on the stage based on the coordinate plane. The best way to use the go-to XY block is to first position your sprite where you want it to be on the stage. Then drag the go-to XY block into your script. Once you position your sprite, the X value and the Y value will automatically be filled into the white circles. What is the difference between the go-to XY block and the glide seconds to XY block? Well, the go-to XY block will place your sprite in a specific location on the stage without you visibly seeing it move to that location. It will just appear in the location. The glide seconds to XY block will also move your sprite, but it will move it from its current position on the stage to the specified XY position defined in the glide to block, and you will physically see the sprite moving slowly from the current position to the other XY position on the stage. Here are some instructions on how to use the go-to XY block and the glide seconds to XY block. First, move your sprite to the position on the stage where you want it to start each time the green flag is clicked. Then drag the go-to XY block into your script below the when green flag clicked block. This will automatically have the X and Y positions filled in because you have already positioned your sprite on the stage. When you click the green flag, this will place your sprite in the same position each time the program runs. Now, let's say that we want the sprite to move from the chair to the top of the table when we run our script. So first, we need to move the sprite from the chair to the top of the table. Then we will drag the glide seconds to XY block and add it underneath the go to XY block in my script. Just as with the go to XY block, once you position the sprite on top of the table, the glide seconds to block will also include the X and Y position automatically in the block's X and Y circles. Now, we want to move the sprite from the top of the table down to the other chair. Again, first we move the sprite to the next position, to the chair on the right side of the table. Then we drag another glide seconds to XY block to the bottom of the script. And again, the X and Y position is already added to the block because we've placed the sprite where we want it to be when it glides to. Now, if we run the script, first the sprite will appear back on the chair on the left side of the table where he started. Then he will slowly move or glide to the top of the table. Then he will slowly move or glide to the chair on the right side of the table. These two blocks are extremely useful and used very often in scripts, as you will see as you start building more projects in Scratch. This will be the second time that your students have worked on a project using the TIPP&SEE protocol. So you may want to go over TIPP&SEE with them again or play the TIPP&SEE video. Remember, TIPP&SEE is a guide to help students walk through and understand a project. They'll look at the title, the instructions, the purpose, and then play the project and answer some questions that will allow them to further investigate how the project works. Then they'll click See Inside and examine the sprites in the event blocks to explore the project by predicting which blocks will do certain actions. Finally, they'll tinker or make changes to the project to see how the changes will affect the actions of the sprite. The TIPP&SEE project we have for this unit is called Sequence on the Farm. Let's start out by doing the tip. The title tells us that in this project, your students will observe sequences of actions on a farm. The instructions tell us to click the green flag to start the project, then click on Roo the Rooster. The purpose of the project is to experiment with how the order of blocks matters when building scripts. Let's run the project. I'll click the green flag. Roo says, "Hi, I'm Roo. Click me to help me wake up the animals." And I'll click on Roo. That would certainly wake me up. All right, so nothing else happens in this project yet, but that's going to be our job as part of the TIPP&SEE. You can briefly go over the 3 different sections of the TIPP&SEE so your students understand what they'll be expected to do when they go back to their computers, open up the Sequence on the Farm project, and open up their workbooks to the TIPP&SEE worksheets. Your students will click on Roo and then identify the sequence of actions that Roo does when you click the green flag or when you click on Roo. Since this is a unit on sequence, you'll be looking at the actions that happen first, next, and last. In section 4, Students will click See Inside and then click on Rue in the Sprites pane to examine the scripts. They will then predict that when Rue is clicked, which block will make the first thing happen, the next thing happen, and the last thing happen. These refer to the 3 actions they identified in section 3 that are on the previous page in their workbook. Finally, in the Explore section, students will change Rue's Glide Seconds to block in 2 different ways. One way will make Rue move faster or slower. The other way will make Rue either move or stay still. Remember, in the Explore activity, students are to predict first what they think will happen based on the change that they will be making in the block, then make the change, and then finally run the code and verify if their prediction was correct. Now it is your turn to complete the TIPP&SEE.